In this video, I want to take some time to clean up app.js. And I'm not just talking about easy stuff like removing the comments from up above, but stuff that's a bit more complex. So far in this course, we've focused on creating methods and functions to abstract away a more complex task into something easy to use. For example, making a guess. There's quite a bit of code that goes into that process, but as far as this file is concerned, it's easy. We just call make guess, passing in the guess. We do not care what happens behind the scenes. Now, in a little bit, we're actually going to want to get a puzzle in app.js to pass it in here. Are we really going to be concerned with all of the logic for making the request and parsing it, checking for errors, and doing all of that sort of stuff? And the answer is no. This file doesn't need to be concerned about that. The real goal is to abstract this away into a function that we can call whenever we need a new puzzle. We're not concerned with where the puzzle comes from or how it gets it. We just know we need a puzzle and we want access to that data. So let's go ahead and kick things off by creating a new file where we can define some functions, allowing us to easily make our HTTP requests and allowing us to obviously make them twice. We can call the function twice as opposed to needing to copy and paste this code. I'm going to kick things off by making that new file in the Hangman folder. I'm going to call it requests.js. Excellent. Now all we have to do is actually link it in. Over in index.html, I'm going to link it in up top. We got our script tag. We have our source attribute, and the attribute value is the file name, requests.js. Perfect. I'm going to save the index.html file, and I'm going to clean things up just a little bit by closing person.js and getset.js. We're going to focus on just the files actually in the Hangman folder. To start, I'd like to actually ignore all of the code down below that makes both of our requests. And to make sure it's completely ignored, I'm just going to comment all of it out, so it's not actually running. What we want to focus on is how we're going to transfer information first, then we'll actually bring in the code that gets the puzzle. Now what we're going to do here is call a function. So we're going to have a function, something like getPuzzle. This is going to go off, it's going to fetch the puzzle, and it's going to give it back to us. Here's the catch though. We're not going to be able to call getPuzzle like this and get the value as the return value. For example, const puzzle. And this might not be obvious at first, but we're going to explore why this is just not possible with what we have so far, and we're going to explore the alternative. So let's go ahead and actually define getPuzzle. Over inside of requests.js, I'm going to create it, const getPuzzle, and we're just going to set it equal to a regular function. And before we actually add any useful functionality in, I'll just return something. So I'm going to return my new puzzle, for example. So in this case, we are indeed going to get everything working as expected. The puzzle variable is going to equal the string returned, and I can log it, console.log puzzle. I'm going to save app.js, and what we get over in the browser really shouldn't surprise us. We get my new puzzle printing. This is great, and clearly it works for the current setup. The problem is that the getPuzzle function has the data to return right away. This is not going to be the case when we actually introduce the HTTP request. We have to wait for the callback function to fire first. Then and only then do we have access to the data, so returning directly from getPuzzle is not going to be possible. Let's go ahead and actually prove that. I'm going to take all the code for that first request, starting with the request variable and going down to request.send. And I am going to uncomment it. Then all we're going to do is cut it out and bring it over to the other file. Over here, we're just going to paste it right into the function body. Excellent. So at this point, we haven't changed a single thing. Now, if we were to run the program, what would happen? Yes, we would still see the data printing to the console. That's fine, but that's not what we want. We don't want to print the data to the console. I want to be able to access the data over here so I can do something meaningful with it, like pass it into the new Hangman constructor function to actually start the game with whatever puzzle comes back. Over inside of the requests.js file, we might think we can solve this using return. Right here, we have the data. We just return it, return data. Well, this isn't actually going to work, and there are a few important reasons why. The first is that it's returning from the wrong function. When we use the return statement, we return from the function we are currently in. Whereas this code, it is not directly inside of getPuzzle. There is a closer function it's related to, that is the callback function here. So I cannot return from a parent function inside of a child function. The return statement applies to the function that the code is executing from. That means return data isn't going to solve our problem, and we could actually go ahead and prove that. If I save both files, what do we get? Over here, we are not getting our data printing. Instead, we're getting undefined. Now, this brings us to the second important reason why this return statement isn't going to work. Look at the order that things are happening here. We're going to explore the live reload comment. The first one we get is undefined, coming from app.js, and the second one is our puzzle coming from requests.js. And this might not have been the order we expected, but it is indeed the correct order. That is because going off and making an HTTP request takes a bit of time. Now, in the grand scheme of things, it's a very short amount of time, maybe 100 milliseconds, but that's a whole lot of time when it comes to executing JavaScript code. Executing code that lives on your machine is super fast. We could execute thousands and thousands of lines of code before a single HTTP request is actually made and processed. That is because going off to the network and finding that server, letting the server process your request, and then sending the data back all takes time. So the order that's happening over here is just further proof that at no point is return going to work, because this code that's supposed to use it actually runs before we ever have access to the data. And we just proved that by seeing undefined printing before the data prints. There's one more common solution that people usually turn to or try to turn to when they want to keep their code looking like this, and that is the following. They start by creating some sort of variable up above, let data, and we'll leave it as undefined. Then they try to manipulate data inside of the callback function. So instead of returning or printing it, we're not even going to create a local variable. I'm going to set data from up above equal to JSON.parse, whatever comes back from that. So here we are changing this variable, then we just return it. So I return data just like this. Now, this code might work, but let's think about what's really happening. Yes, we are creating a variable, we're trying to change it, and we're returning it. The problem is that we return from this function well before this callback ever fires. And we can prove this once again by just saving the program and seeing what happens. Right here, we are getting undefined printing because data is undefined. We return from the function, and we print the return value before this code ever actually runs. So none of these solutions are going to help us solve the problem. Let's talk about what is going to help us solve the problem, and that is the callback function. Now, lucky for you, you actually already have some experience with callback functions. A callback function is when we pass a function to another function. In this case, we pass our function that we've defined here to add event listener. Behind the scenes, our function gets called by the function we pass it to. Now that's quite a mouthful, talking about a lot of different functions, so let's go ahead and explore this pattern without worrying about any of this code. I'm just going to comment this code out, and up above, we're going to pretend it doesn't exist, and we're going to explore the most basic callback pattern possible. So in the end of the day, we're not going to return anything from getPuzzle. Instead of relying on a return value, we're going to rely on a callback function. So no longer do we return anything from getPuzzle and expect it to exist. Instead, we pass a function into getPuzzle. So right here, I'm going to define my function. This function is where we get our work done with the puzzle that we've just fetched. In our case, the only thing we're doing is printing it. So I can take this line, I can cut it out, and I can paste it right in. Now, the callback function gets called with some information. We've seen our event listeners get called with their event argument. We can have our callback function called with as many arguments as we like. For example, right here, I can have it called with the puzzle so I can actually print the puzzle. So this is how we use the callback function. The question is, how do we actually set that up? Over inside of requests.js, we are going to name our first argument. What is the first argument that got passed into getPuzzle? It is the callback function. So we can call it something like callback. Now, callback is a function like any other function, like getPuzzle, which means we can execute it whenever we need to, and we can pass arguments to it. What we're going to do right here is call it. I am going to call callback. I'm going to pass it the arguments it expects. What does our callback function expect? The callback function lives right here. It expects a single argument, which is the puzzle that was fetched. So all I'm going to call it with is that puzzle right here, some fake puzzle, for example. Now we can go ahead and actually save both files. And what we're going to see in the terminal is that some fake puzzle prints from line 16 of app.js. That is the line that's sitting right here. Now, this isn't particularly interesting because we could have solved this problem using a return value, but now we can integrate the callback pattern into the code down below. So let's go ahead and do just that. I am going to remove the callback function call. Then I am going to uncomment all the code we had below, and we're going to clean it up a little bit. We're going to remove the return statement we added in, and we're going to remove the letData variable we created up above. And we are going to recreate const data right here like we had before. Now what do? We don't try to force return in here. It's not going to work. All we do is we call our callback function passing in the data. In this case, that is data.puzzle. Perfect. Let's go ahead and save the requests.js file and see what we get. What do we get? I get designer denim jeans showing up, and it is not showing up because it's logged in the requests file. It is showing up because it's logged in app.js, meaning that our callback pattern worked successfully. So by taking advantage of nested functions and lexical scope, we're able to access the parent scope's callback variable from this function, allowing us to respond to the request from app.js. Now, when we're working with this callback pattern, it's actually common to accept two arguments to the callback. The first is any potential error, and the second is your success data, which in this case is a puzzle. That makes it really easy to do one thing if the program crashes, if getPuzzle can't do its job, and another thing if getPuzzle does its job correctly. Right here, we can set up an if statement. If there is an error, we can go ahead and do something else. We can do something else. Let's go ahead and remove this console.log and actually knock this out. If there is an error, we can print console.log. I'm going to print a template string with error, :space, then I will inject whatever the message was. So right here, error. Then down below, if things go well, for the moment, we'll still just log it, though later we'll actually pass it to new hangman. Console.log, printing puzzle. So all we're doing here is checking if the first argument exists. If it did, then something went wrong and we're going to run this code. If it doesn't, then something went right and we're going to use this code. So when we're working with the callback pattern, we define at most one. One of these is always going to be defined, but never both and never none. Things either went well or they did not go well. There is no alternative where both things happen, where we got an error and things went well. So let's go ahead and actually make this code work because currently it does not work. The first argument we're passing to the callback is not an error, it is the puzzle itself. Now in this case, there is no error. Things went well and we have the data. So for the first argument, we're going to pass in undefined just like this. And for the second argument, we're going to pass in the puzzle. Now down below, we can remove this code and replace that as well. I'm going to call the callback. This time, we actually do want things to have an error, so we are going to provide that first argument. It is going to be a string. We can use the same string we have down below or something slightly different. An error has taken place. And for the second argument, which is the success data, we actually don't want to define that for the error, so we can leave it as undefined. Now remember, undefined is the default argument value, so you can actually leave this off altogether. I'm just leaving it here for clarity. We can now remove our console.log call, and now whether things go well or poorly, the callback function gets executed. I'm going to save requests.js and app.js. Over here, I am still getting my puzzle printing as expected from app.js line 19, which is this line here. Let's go ahead and trigger an error by messing with the request. I'll add that extra t back onto word count. When I do this, we do correctly get our other error message from line 17 of app.js. Error. An error has taken place. Now we can go ahead and remove this t, and there we go. We have our callback pattern all set up. The person who calls getPuzzle can access the data or any potential errors that might take place, even though the data doesn't live directly inside of the getPuzzle function. GetPuzzle has to go off and fetch that data first. That's where I'd like to stop for this one. Let's take some time to recap what we did, because we did cover quite a bit. The big picture goal in this video was to create a function that we can call from app.js to get the puzzle. I did not want to have all of the code for actually setting up the HTTP request and parsing the data over here. Instead, I wanted to keep this file simpler, just calling getPuzzle. Now, we originally tried to solve this using return by expecting the puzzle to be returned from getPuzzle, but as we saw, that wasn't possible because what we have here is an event listener which does not fire until after this function completes, which means that we cannot use return anywhere inside of this file to solve the problem. The solution was to use the callback pattern. In the callback pattern, we don't expect anything to be returned from getPuzzle. Instead, we pass in a function and we expect that function to be called with the information when it's actually ready. In this case, we used a pretty standard callback pattern, where the first argument is a potential error and the second argument is your success data. Only one of these is ever going to be defined. Either things went wrong or things went well. Now, to actually use this over inside of requests.js, all we did is we called it when we had the data. Right here, we called it providing the second argument when things went well. Down below, we called it providing only the first argument when things went poorly. Now, don't worry, we're not done talking about what's happening here. I have a lot more to say about how this is working behind the scenes and alternative ways to get this done. We're going to get into all of that in the next video, so let's go ahead and jump right into that one.